Hey everybody, this video is on section 3.1, exponential functions. So let me write that down. Chapter 3.1. It's on page 198. Alright, so we're talking about exponential functions. Here's a brief description of what an exponential function is. F of x equals a to the x. And a is greater than 0, and a cannot equal 1. All right, so, and a is called the base, right? So this is your base. Your exponent, x, it can be any real number. So x can be an element of the real numbers. Okay, so there's a restriction on a and restriction on x. And I'll just graph sums to give you an idea why that is. So if I do like f of x equals, let's say 1 raised to the x power, you see you get a graph that's just a horizontal line, right? That's all it is, horizontal line. So it's not exponential. This number has to be bigger than 1. So if I make it instead 1.1, now we have something happen. We have growth. 1.2, it's going to grow faster, right? If I make it 2, it's going to grow even faster. It can be smaller than 1. It could be 0.9. Then we think of this as decay, right? It's as x is getting bigger, y is getting smaller now. So we could do 0.8, 0.5. So the closer it is to 0, the faster it decays. As you get close to 1, it gets more and more horizontal, right? So if we do 0.99, you can see it's almost horizontal. And if I get closer to 1, it gets closer and closer to horizontal where you can't even tell it apart. All right, so 1's a no-no. We can't have the base be 1. That's not allowed. And of course, it can't be 0. And it can't be negative. So I can't have -2 here. Well, the negative's outside. What I mean is, let me see if I can explain that a little better. Here we go. You can't have negative because now the graph is jumping all over the place. Since every time you put it, like, for instance, if I make a slider with x, how do I make a slider with x? I can't remember. But if I put f of like a negative, let's do f of 2. I get 4. What if I do f of -2? I get 0.25. Interesting. That's not what I expected, but let me see if I can explain from the graph itself. Look at these points. Notice how they're up here, right? And they're down here. They're jumping around. And the reason they're jumping around is because when you raise a negative number to an even power, you get a positive. But when you raise a negative number to an odd power, you get a negative. So all this to say in a very awkward and clumsy way that you can't have a negative for your base. It's got to be bigger than 0, and it cannot be 1. All right. So let's talk about exponentials in general. We're going to go back just real quick, just to remind you of some basics. Multiplication, back when you learned it, it's just a, think of it as a shortcut for addition. So if I have 5 plus 5 plus 5, which is 15, we learned the shortcut 3 times 5, which is 15, right? So we know that multiplication is a shortcut for a repeated addition, repeatedly adding the same things over and over and over. Well, exponentials, like 5 times, I'll use a smaller number, make my life easier, 2 times 2 times 2, that is 2 to the third power. So repeated multiplication's shortcut is exponents. All right. Also, recall that if you raise the exponent to a negative number, you don't get a negative number. You actually get a fraction. So we know that 2 to the third is 8 because 2 times 2 times 2 is 8. 2 to the negative third is actually 1/8. So the negative doesn't make the answer, the negative exponent does not make your solution here negative. It just makes it small. It makes it close to 0. All right. Okay, so let's look at some problems from your textbook. This is on page 206. I'm going to look at a couple of these real quick. So we'll do number 2. Number 2 is f of x equals 2.3 to the x power. And we want to know what the value is when x is 3/2. So what we're looking for here then is f of 3/2, right? So that'd be 2.3 raised to the 3/2 power. And let's do that on my calculator, show you how that's done. So you're going to just put in 2.3, hit the raise to button over here, and then you can just put in 3/2. And that gives you about 3.488. About 3.488. Oh, did I do the right one? I did. Okay. Yeah. All right. So that is number 2. We'll do number 4 as well. Number 4. Is g of x equals 5,000 times 2 to the x. All right, now I'm going to rewrite that. That x can be pulled out of there, so I'm going to rewrite that as 5,000 times 2 raised to the x. And we want x to be negative 1.5. So we're looking for g of negative 1.5. So all we do is replace this with negative 1.5, so 5,000 times 2 raised to the negative 1.5. And we'll just put that in our calculator. 5,000 times 2 raised to the negative 1.5. About 1767.77. So 1767.77. Now notice these are all approximations, right? Because I'm rounding. And that's all there is to that. So in this first section, all you do is you plug in the x value given to the function. I guess we should do E. Let's talk about E for a minute. So number 6 is f of x equals e to the x. So E is a number. You can look up where it comes from. There's a pattern to that generates E. It has to do with factorials. But on your calculator, it's right here. It's the division button. So second divide is, and you can see E is approximately 2.718281828. It doesn't repeat. It does actually change after that, after a while. So I wonder if Desmos has it. Let's see. Maybe Desmos will give me E. There it is. So 2.71828182846. See, it changes right after that. So it looks like it's going to repeat 18281828, but then it starts changing. So E is a irrational number, just like pi. Okay, it's very useful when we're dealing with exponentials and logarithms. It's commonly occurring in nature, as well as in man-made things. It's an interesting number. You look it up. There's just a lot of literature out there on this number. But what we're trying to find here is, let's see, what did I do? Hold on. Oh, there it is. Okay, so I'm on number 6. I'm looking for when x is 3.2. When x is 3.2. So we want f of 3.2. Okay, so once again, get our calculators out. Second divide gives me E. Raise that to the 3.2 power, and I get about 24.53. All right, and then we get into the graphs. And part of this is looking at the stuff we already learned back in chapter 1 and 2 when we were looking at translations and reflections. So for instance, you've got this basic function, f of x equals 2 to the x. What happens to it if you add 1 to it? Well, if you remember, it just shifts it up 1, right? What happens if you make x negative? Well, if you remember, that's a reflection over the y-axis. What happens here if you take 2 away from x? Well, if you remember, that moves it to the right 2. All right, so if I know which one of these is the basic one, then I should be able to find the other ones. Now, I know this is a growing function. In other words, as x gets bigger, y is going to get bigger too, right? Because 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8. So it can't be this one, because this one's getting smaller as x, so it's definitely not that one. It's got to be one of these 3. Now, of these 3, only one of them crosses at 1, so I think it's this one, because when I make x 0, anything to the 0 power is 1, so that's right there, right? So if I do, oh, that's not 1, that's 11. So let's do 2 raised to the 0 power, and notice I get 1. Okay, so it's got to be this one. So this one goes with 7. 7 goes with D. All right, now this one, we already mentioned, number 9 is a reflection over the what? Well, if x is negative, it's a reflection over the y-axis. So that will flip this over the y-axis. So that's this one. It's got to be, because that's the only one that's turned across the y-axis. So number 9 has to go with A. And then this one takes this original function. Remember, the original one is this one. And it just shifts the whole thing up 1. So this, where it crosses at 1, should cross at 2. So that must be this one, right? So number 8 goes with C. And the last one, obviously, which is this one. Remember, when you take 2 away from x, it should shift the whole thing to the right. So if this is the original one, as we said, you're going to drag that to the right. So this is going to come down here a little further and cross a little lower, cross the y-axis a little bit lower, so it's that one. So 10 goes with B. All right, and you could also put those in Desmos and easily pick them out. But you should be able to do what I just did just by looking at the functions in the graphs. All right, in the next section, it says use graph of f to describe the transformation that yields the graph of g. Okay, so again, similar to what we just did. So let's look at number 12, I guess. So number 12 is f of x equals 4 to the x. Versus g of x, which equals 4 to the x plus 1. Now, notice that's a big plus 1, which means you're adding 1 to the whole function, right? Not to the x, but to the function itself. So that is a shift up. So this is a vertical shift up 4 units. That's it. That's all you got to do. And let me show you. So f of x equals 4 to the x. Oops, great. So there's that graph. And then we'll do g of x equals 4 raised to, to the x. And then out from there, we're going to do plus 1. And what that should do is just take this original graph here, and it should move everything up 1. There it is. So it went up from here, where it crossed at 1. Now it should be crossing at 2. There it is. All right, so bumped everything up 1. This, wherever it was crossing, it now crosses up 1 higher. Okay. So that was number 12. Next, let's look at 14. So 14 is f of x equals 10 to the x versus g of x equals 10 raised to the negative x plus 3. This one's tricky, all right, because the x is negative. So what I recommend here is to figure out what happens. So the first thing I would say is, well, if you add 3 to x, it's going to shift it left 3. But you're not adding 3 to x, you're adding 3 to negative x. So the opposite should be true. It's going to shift it right 3 places, right? So now one way to see this is if I factor that a negative out of this, and then make that'd be positive x, and that would have to be a minus 3. Now we can look at this minus 3 as a shift to the right, and then that negative as a reflection, right? So that's going to be a reflection over the y-axis. So ten to the x is going to cross here at 1. And it's going to grow pretty quickly, right? So even at 1, it's going to be way up here at 10, right? Because when x is 1, y is 10. 10 to the 1 is 10. So it's going to, it's going to do something like this. It will shrink very quickly as well. It's going to get very close to the x-axis quickly. All right, so that's what this one looks like. Something like that. Well, when I do this x take away 3, that is going to shift everything to the right 3. So that means this point is going to move over 1, 2, 3. So now it's going to do something like this. But. What's confusing about it is I've changed the order of operations here, right? That negative, if I do the negative first, then it would be this. Let me do that first. What was originally given. So it looks like this. All right. So I'm looking at that. And now when I add 3 to that, well, I'm adding 3 to the opposite of x. So it's going to, normally when I see that plus 3, I think it's going to go left, but I believe it's going to go right. So I think this is going to go 1, 2, 3 this way. I think it's going to do this. So I think we're going to end up like right here, but I'm not positive. Let's graph it and see. All right, f of x equals 10 to the x. All right, there's the original, right? The one I drew in pencil. All right, now we're going to do g of x equals, and I'm hoping this is what it's going to come out to look like. So 10 raised to, and I'm going to put in what's originally given here, negative x. All right, so I did that, right? When I did negative x, it gave me this graph. And then when I add 3, I'm thinking it's going to move it to the right 3. Dang it. I think I have to put this in parentheses, I think. Negative x plus 3. Yes, it worked. All right, so that's right. So without the 3, it's right there. It's simply a reflection across the y-axis, as you can see. And then when I hit plus 3, it moves it right. Well, why does it move it right? Well, because it's a negative x we're adding to. So plus 3. Here we go. So that's number 10. All right. We'll also do number, wait, what number was that? That was 14. 14. Okay. So let's look at next number 20. These are all the same. So 20. F of x is 1/2 raised to the negative x. And the question says, use a graphing utility, construct a table of values for the function, then sketch the graph of the function. All right. So what we're going to do is we're going to put this in our graphing calculators. Y equals, parentheses, 1/2, close parentheses, raised to the negative x. And then we're going to go to second graph. Now we can go to graph and look at, this is what the graph looks like. And then when we go to second graph, we can get to our table of values that we were asked to look at. So our table of values, I'll just do x and f of x right here. And looking at my calculator, I've got, we'll start at -2 is 0.25, -1 is 0.5, 0 is 1, 1 is 2, 2 is 4, 3 is 8. All right, so the graph so I go to -1, -2, and that's up to 0.25. Here's 1, 2, 3, 4, 5, 6, 7, 8. -1 is 0.5, so it's a little bit higher. 0, 1 is right there. 1, 2 is about here. 2, 4, so there's 2, 3, 4 is right about there. And 3, 8 is right there. So it does something like this. There it is. All right, let's talk about what that negative does. Now that negative, actually, you could get rid of the negative if you flip this fraction over. So negative, for instance, 1/2 raised to the -1 is the same as 2/1 raised to the +1. Now, hopefully you remember that back from Algebra 2. So let's look at the graph of each of those real quick. So our calculator, I'll just do it on this one. Here's the graph that we had. That was the 1/2 raised to the -x. So if I go down here and do 2 raised to the +x, and I'll make this one, I'll show you a new trick. I can make the line different. I'll make it have this circle thing. All right, so now graph, here it comes. Didn't show up. Let me try that again. Line. Oh, I didn't hit OK. OK. All right, now when I hit graph, here comes the original function, which is 1/2 to the -x. And here comes, you can see that little dot moving, showing you it's the exact same function. All right, let me do it on here too. Y equals 1/2 raised to x versus y equals 2. Wait, sorry, that should be -x. -x. Get in there. There we go. 2 raised to the +x. Notice they're the same graph, right? So negative exponents can be eliminated by taking the reciprocal of the base. All right. So that was what? Number 20. 20. And then, yeah, that's the way all these are. So we're just looking at graphing these different graphs and seeing what they look like. There's another one here I wanted to do. I thought it had absolute value in it. I don't see it now. Oh, maybe it's this part, yeah. So in 33 through 42, use a graphing utility to graph the exponential function. So there's one, number 34. 3 raised to the negative absolute value of x. Let me show you how to do that on Desmos. So I'm looking at 34. It's y equals 3 raised to. Now, to get the absolute value, I'll start with, it actually says negative absolute value of x. Type in ABS, and then parentheses x. And there's function. It's the same way on your graphing calculator. So let me do it on there as well. So we're going to go into y equals, get rid of that, get rid of that. We want to do 3 raised to negative, remember negative's down here by the enter button, 3 raised to negative, it's too bright. Now absolute value is under the math button. You go to math, and then I think it's under number. Yeah, it's right there, ABS. Absolute value x. And there's your graph. Same as on Desmos. All right. So that's all you do on those. You just graph them and draw a sketch of those problems for this section. And then the next section, this is where we get into actual applications, and I'll save that for another video. Try to keep this one short. Appreciate you guys watching. If you have any questions, please email me. God bless you. Have a great day.